Our next exploration of transformations from section 3.5 talks about horizontal stretches and compressions. Now we just saw vertical. What is different about this? Last time we were multiplying by 2, we were multiplying by half. We started with the square function. This time we're just going to use a different one. This is the parent function of the absolute value function, right? But notice what's different. We are going to multiply before we evaluate the original function, before we take the absolute value. And the last one, we squared and then multiplied. So that's very important to notice the difference. When we evaluate the function and then do the transformation, that's been vertical. Notice the word vertical attached to that every time. Exploration 1, exploration 3, and exploration 2, we added 1 inside the absolute value, and that was horizontal. And again, now it's inside the absolute value, horizontal. So let's see how this goes. For f of x, we should be familiar with that now. If you take the absolute value of -2, you get +2. -1, you get 1. 0, you get 0. 1, 1, 2, 2. So here's our original parent function, the absolute value function. All right, here's f of x. All right, so let's make some tables for g of x and h of x. So g of x equals the absolute value, 1/2 x. X and g of x. Let's choose our same points. We'll do -2, -1, 0, 1, and 2. Okay, multiply a half times -2, you get -1, and the absolute value of -1 is +1. Multiply a half times -1, you get -1/2. Absolute value is 1/2, 0, 1/2, and 1, right? Okay, -2, +1, -1, 1/2, 0, 0, 1, 1/2, and 2, 1. So what we're seeing, we're still at 0, 0, but notice now we've come out here on the outside of our original parent function. Here is g of x. Okay, and then h of x, we're going to take the absolute value of 2x. -2, -1, 0, 1, 2. -2 times 2 is -4. Absolute value is 4. -2 times 2 times -1 is -2. Absolute value would be 2, 0, 2, and 4. So we have -2 and 4. We have -1 and 2. 0, 0, 1, 2, and 2, 4. And now we find ourselves inside that original parent function with our h of x. Okay, this is a horizontal stretches and compressions. So what has happened for g of x? Horizontally, it has stretched. Notice if you're thinking horizontally, to go from the original f of x to get to g of x, you have to stretch horizontally, right? So this is a horizontal stretch by a factor of 1/2. This is and then now to get h of x, you're not pulling horizontally, you would be compressing. You'd take your f of x and pushing it this way, compressing it in, and you would end up with your h of x. So this is a horizontal compression by a factor of 2. Okay, so the thing to notice is that for the vertical, it was a stretch when the number was, we were using the number 2, right? And that ended up being a stretch. But for the horizontal, when we used a 2, it was a compression, right? And same thing for the 1/2. For the vertical, the 1/2 gave us a compression. For horizontal, the 1/2 gives us a stretch. We'll be summarizing all of this here in a little bit.